So you may know Euler's identity. E to the I pi plus 1 equals 0. And you may know phi, the golden ratio. It has the property phi squared minus phi minus 1 equals 0. So it's a root of the equation x squared minus x minus 1. So what I'm going to be doing today is I'm going to be extending Euler's identity to use phi and eventually square root 2. So I'm going to do a little bit of algebra right here. So phi squared minus phi equals 1. Phi squared equals 1 plus phi. So we're going to be using this. And we have the equation e to the I pi plus phi squared equals phi. So this is true because we have negative 1 plus phi squared equals phi. As in phi squared minus 1 equals phi. We get phi squared minus phi minus 1 equals 0. There. So we know this is true. And we can divide both sides by phi. So we get e to the I pi over phi plus phi equals 1. And we can rewrite this as e to the I pi over e to the ln phi plus phi equals 1. So e to the I pi minus ln phi plus phi equals 1. And now e to the I pi minus ln phi plus phi minus 1 equals 0. So now this is sort of in the form e to the something plus another thing equals 0. So, e to the x plus y equals 0. So x equals I pi minus ln phi and y equals phi minus 1. But we can rewrite this once more to change phi minus 1 to something. You could say it's a little bit simpler. So phi minus 1, to get that, we can say phi equals 1 over phi plus 1, divide both sides by phi. And we have phi minus 1 equals 1 over phi. 1 over phi equals phi minus 1. We plug that in. So we have e to the I pi minus ln phi plus 1 over phi equals 0. And I'm going to be doing one more thing to get another equation. So we have phi squared equals 1 plus phi. So we can use a little bit of algebra to get phi squared minus 2 equals phi minus 1 equals phi plus 1. Subtract 2, we get phi minus 1. And now we have phi minus 1 equals phi plus square root 2 by phi minus square root 2. This is how square root 2 comes into play. We can basically just plug this in. So we get e to the I pi minus ln phi plus phi plus square root 2 by phi minus square root 2 equals 0. And this is also in the form e to the, this is e to the x1 plus y1. X1, y1. So this is e to the x2 plus y2, where x2 equals I pi minus ln phi. Phi equals the product phi plus square root 2 by phi minus square root 2 equals 0. And yeah, that's basically it. So I'm going to rewrite this. And yeah, so these are the two equations. Equation 1 has e I pi 1 0 phi phi and square root 2. And then equation 2 has e I pi 0 phi. So yeah, e I pi 1 0 phi, e I pi 0 phi square root 2. So there is a bijection, meaning each equation has the same number of constants. So cardinality set A equals cardinality set B. But you may argue that this one has better constants, or maybe this one has better constants. That's up to you. Equation 1 has plus, minus, times, division, and is exponentiation and logarithm. And then equation 2 has plus, minus, times, exponentiation, and logarithm. So there is not a bijection between the elements. One is left out. This one is left out. But that's okay. So they both have their pros and cons. You know, you might think that equation 2 has better constants, but it does have one less operation. You do think that equation 1 is better because even though equation 1 doesn't have square root 2, it does have 1. Yeah, and it does have one more operation. Yeah, so that's basically it. I hope you like this video, and see you in the next one.